Scientists have outlined a practical experimental route towards synthesizing element 120 by adapting heavy ion fusion techniques, most notably using a titanium beam to produce heavier nuclei and point the way to unbinilium. The search for element 120, unbinilium, has long been framed as the next great challenge at the edge of the periodic table. Recent work from teams connected to Lawrence Berkeley National Laboratory describes a shift away from the calcium-48 beam strategy that produced the heaviest known elements and toward heavier projectiles such as titanium-50, which can fuse with suitably heavy targets to form new super-heavy nuclei. That methodological pivot is significant because it circumvents the shortage of ideal target materials and opens experimental options that were previously impractical. The new pathway rests on incremental, demonstrable steps rather than a single leap. Researchers report success in producing livermorium, element 116, using a titanium beam, demonstrating that the technique can yield super-heavy nuclei with measurable cross-sections and lifetimes long enough for detection and study. This empirical proof of concept matters. It shows that heavier projectiles can be tuned to overcome fusion barriers, and that experimental facilities can adapt beam and target chemistry to pursue elements beyond 118. The approach also reframes how laboratories plan target production, beam time, and detector configurations for the next generation of synthesis attempts. Practical obstacles remain. To reach elements 119 and 120, experiments traditionally require targets made from very heavy actinides, such as einsteinium or fermium, which are scarce and difficult to produce in the quantities needed for bombardment experiments. The titanium beam strategy reduces, but does not eliminate, these supply constraints by changing the combination of projectile and target nuclei, yet it still demands extreme precision, long irradiation times, and detectors capable of distinguishing rare decay chains from background events. These logistical and technical challenges mean that even with a clear pathway, successful synthesis will require coordinated international effort and sustained facility upgrades. Beyond the technical feat, the discovery of a viable route to element 120 carries deep scientific promise. Theoretical models predict that unbinilium sits near the hypothesized island of stability, where certain super-heavy isotopes might exhibit relatively longer half-lives and novel chemical behavior. Confirming those predictions would reshape nuclear theory and expand our understanding of atomic structure under extreme proton counts. If synthesized and characterized, element 120 could reveal unexpected electronic configurations